So far, in this section of the course, I've focused on JDBC as the means for communicating with a database. This is for good reason, since it's part of Java's Standard Edition implementation, or core Java in other words. We've walked through writing SQL statements and executing them for the usual CRUD functionality. I've also demonstrated that this work can be more tightly knit to the database server by utilising stored procedures that have been written to do some of the work for you. Even so, you're still in the business of having to write some database interaction code. The alternative is something called the Java Persistence API, or JPA for short. JPA is a specification. There's no default implementation of the specification provided in Java's Standard Edition. That being said, I still want to cover the topic briefly. There's a very good chance you'll be working on an application that uses some form of it. Some popular implementations are Hibernate, Spring JPA, and Eclipse Link, to name a few. These are called JPA providers. In 2019, the Java Persistence API officially changed its name to Jakarta Persistence API. It was previously part of Java's Enterprise Edition, which has since become open source. The Persistence API became one of the Jakarta projects. The link shown on this slide is Jakarta's API documentation for JPA, and unless you're supporting legacy code, you should start here. A few of the key concepts of the JPA specification include a technique known as Object Relational Mapping, or ORM, the entity, which is the mapped object, and the entity manager, which manages life cycles of these entities. The persistence context is a special cached area where the entities exist. You can think of JPA as an extra layer of functionality between your application code and the JDBC code you saw in the last lectures. Object Relational Mapping is a method of mapping database tables defined by columns to a class with correlated fields and setters and getters. A record in a table then becomes an instance of one of these classes. ORM frameworks often automate the process of object relational mapping. They simplify code, reducing the need to write boilerplate classes. They simplify database operations, hiding the complexities of SQL queries and handling database interactions for you. They provide code portability across different database systems. ORM frameworks also encourage a more structured and organised approach to data access. Typically, an entity is a class that represents a table in a relational database. Each entity instance corresponds to a row in that table. Each entity is annotated with metadata to instruct JPA providers how to map its fields to a table's columns, relationships to other tables, and lifecycle management techniques to use. The example on this slide is a relatively simple one of an annotated class, artist, which would be an entity for our artists table in the music database that we've been working with. In this example, the annotation entity describes this class as the entity type. A framework implementing JPA will identify entities by this annotation. The annotation that follows next is table further describes the table name, so that is artists in this case. Next, the fields in this class also have annotations which describe their database correlated information. So I have an ID, and that's the artist ID. I include the column annotation, which specifies the ID's column name. Next, I describe the field, artist name, as mapping to the column name, artist_name. After this, I've declared a list of albums for this artist. Above this field, I specify information about the relationship. I use the one-to-many annotation, then the join column with the join ID, so album_ID. The entity manager is implemented by the JPA provider. An entity can exist in a managed state managed by the entity manager, or it can exist in a detached state outside of an entity manager. A detached entity can then be merged into an entity manager if a commit is needed to a persistence layer. There are some key methods on the entity manager interface to know that line up with the CRUD operations. The persist method makes a detached instance managed, and it's this instance's state will get persisted on a commit. The find method searches for an entity of the specified class using the primary key in the persistent layer. It returns an instance that will be managed and automatically persisted. If an entity is managed, updates will be propagated automatically to the persistence layer on a commit. If the entity is not yet managed, a merge method will make the entity managed. The remove method removes the entity instance from management and executes a delete on the persistence layer. I'll be walking through examples of these methods coming up. The persistence context has multiple purposes. It tracks the lifecycle state of managed entities. These states include new, managed, detached, and removed, reflecting any changes you make to their properties. It synchronizes changes made to managed entities with the database. This happens automatically when a transaction is committed or flushed, ensuring the database state reflects the state of your in-memory objects. It performs identity management, ensuring unique entity identity within a transaction. Even if you create duplicate objects with the same identifier, the persistence context recognizes and manages them as a single entity. It acts as a cache, reducing database round trips by keeping frequently accessed entities in memory for faster retrieval. The objective of this lecture and the ones that follow aren't to give you a deep dive into JPA. Instead, I wanted to give you a simple introduction to this architecture, which is used by so many frameworks. Let's get back to some code and start exploring these concepts a little bit in a concrete way. I've created a new project called JPA with the usual main class setup. Before I do anything, I need to include some additional libraries in my project. So I'll go to Module Settings. I'll select Libraries. First, I need to add the JDBC driver for MySQL, which I've done in several projects, so I'll quickly do this. I'll navigate to that jar file and select it and accept all the default settings there. If you've updated IntelliJ recently, you may get an additional dialog. It's titled Detected Routes and says Choose Routes, and for this you just want to hit the OK button, assuming a route is selected, which it should be by default. The next dialog lets me select which module it should be added to, and since I've only got one option, I'll click OK on that. Next, I need the Jakarta JPA module. I could get this module from Maven, but I also need a JPA provider. For the provider, I'll use Hibernate, and that comes packaged with the JPA, so I can just include that one module. I'll get this module from Maven. In the next section of the course, I'll be talking more about Maven, so just follow along with me here. I'll type in org.hibernate.orm and press enter. I'll get this error, but we'll give it a moment and a list should pop up. Rather than scroll down and look for what I want, I can continue to type in this field. So I'll add :hibernate -core in this input field after the org.hibernate.orm. It's important that you don't have any spaces before or after the colon. Now I see the versions of this module listed, and I want to make sure I get one that's the latest version, 6 or higher. For me, at the time of this recording, it's 6.4.1 final. I'll select that. Another dialog pops up. I'll make sure Transitive Dependencies is checked in that dialog and click OK. Now, it's important to examine the classes in the version you picked to verify that you have the Jakarta.persistence-API in this set of classes and that it's at least version 3.1. In addition, you want to verify that the module you pick has Hibernate core there and it's at least version 6. Make sure you apply these changes on the screen by selecting the OK or Apply button. If you aren't seeing Jakarta's Persistence 3.1 jar there, you should try these steps again or alternately manually add Jakarta's Persistence API 3.1 or higher. Since things change more than they stay the same, let me just quickly show you how to add that module separately. If you've verified this package in your module, you don't need to do this next step and can skip adding this module. Again, I'll open the module settings with libraries selected and click the plus button and select from Maven. I'll type Jakarta.persistence: in there. I could hit enter here, which gives me that error, or optionally I can do a search. When you press enter, it's expecting a fully qualified coordinate or module identifier, and in these cases, we're supplying only a part. The search is a bit more friendly, and that's the search icon next to this field. Hitting that rather than enter doesn't give me an error, and it displays information about how many matches it found, and after a slight pause will display them. Now I see the different versions of this package, and I'll pick the 3.1.0 version. You probably don't want to pick any version with M or B in the suffix. These are milestone and beta versions, which may not be the most stable versions. RC stands for release candidate, so again, I just stick to one without those suffixes. This module has a single jar file in it, and you'll see that displayed in the classes list after you add this. Again, click OK or Apply. In my case, I don't need this jar file in my dependencies twice, so I'll simply open module settings again to the library section and remove this Jakarta.persistence module here. Again, it's part of the Hibernate module I included, so for me, it's not necessary. The purpose of Maven is to help us sort these dependencies out, but again, I'll cover that in a later section of the course. Now that we've got the libraries we need, we can get back to coding. I'll start with creating a couple of entities for the music database. There are tools, including a Hibernate plugin for IntelliJ, that will generate entities for you based on your database schema. This plugin is not available, however, for the Community Edition, which we're using. Since we only have 3 tables, I'll create these manually, which is a good exercise anyway as you're learning. So first, I'll create the artist in the dev.lpa.music package. To make this an entity, I simply use the annotation entity. IntelliJ should be able to resolve this annotation and include an import. For me though, I have to select entity by double-clicking and it adds the import. This is part of the package Jakarta.persistence, which is included in the Hibernate core package, as I mentioned before. If I hover over the entity annotation, I can see how IntelliJ resolved it. If you don't see Jakarta.persistence, then you should go back to the installation of the module. Specifically, you really don't want to see JavaX.persistence. This Jakarta.persistence contains all the annotations and the interfaces for the JPA specification. An entity usually has a relationship to a table, so I'll set that up. I'll add the table annotation after entity, but before the class declaration. Here I'll specify the name of the table in the music schema, which is artists. You can see the import was not added automatically, so I'll just click it and do an Alt-Enter and ensure I choose the Jakarta.persistence table like this. My artist table only has 2 columns, artist ID and artist name, so I'll set up 2 fields on this class to represent those columns. I'll start with the annotation ID. Every database entity requires this on one field, which represents the primary key. I'll map the field to the column name, artist_ID, which is the primary key for artists. I'll fix the imports in a bit. And here I'll have my declaration for the field name, so private int artist ID. And again, I'll map the next field, this time to the artist_name column. I'll declare this field as a string and call it artist name. As you saw, the imports for ID and column were added automatically for me. I need some constructors and getters and setters, so I'll generate these, starting with the constructors. All JPA entities are required to have a noArts constructor, so I'll add that first. I'll pick constructor from the Generate menu. I'll click on the Select None button at the bottom of this dialog as the option. That generates my noArts constructor. I'll repeat this process for a second constructor, but in this case, I'll select artist name in the dialog and click OK to create a one-argument constructor. That generates a constructor with the artist name as the only parameter. I'll repeat this one last time, so again picking constructor from the Generate menu. In this case, I'll select both fields, then click the OK button. That's my third and last constructor for this class. Now, I'll add a getter and setter, selecting that combo from the Generate menu. I'll pick just the artist name, since I don't need these methods for the ID. IntelliJ generates the getArtistName and setArtistName methods for me. Finally, I'll include a toString method, and again I'll generate that using Alt-Insert and picking toString from the Generate menu shown. The template might be set to the JSON Builder template from the last challenge as it was for me. I'll instead choose the string concat template from the select list here. I'll select both fields in the next dialog and hit OK. And we are done. I've created my first JPA entity. It's really just an annotated Pojo. I'll close this video here before it gets too long. In the next video, we'll use this entity to communicate with the artist table in the database, so I'll see you in that next video.